Fourth grade lesson 10.7 is find and draw lines of symmetry. Our essential question is, how do you find lines of symmetry? Let's unlock the problem. How many lines of symmetry does each polygon have? Well, we would find the lines of symmetry to see. They are using an isometric and squared dot paper to help them with that, and a straight edge ruler. They've drawn this. They said draw a triangle on your paper, and then fold the triangle in different ways to test for symmetry. Draw along the fold lines that are lines of symmetry. So this is a way, if we're folding the papers, we could find lines of symmetry. Not very easy for me to fold those papers on here, so I'm going to try a different way. As you know, a square has 4 sides. 1, 2, 3, 4. So we can put 4 here. And what are my lines of symmetry? Well, we can see that if I fold it this way, it matches. If I fold it the other way, it matches. So there's 2 lines of symmetry. But because all of the sides are equal, if I fold it diagonally, it will also match one way and the other way, giving us 4 lines of symmetry. Let's look at the parallelogram. Here is our parallelogram. Can I fold it this way? No, they don't match. Okay. Can I fold it this way? No, they don't match. Diagonally? No, they don't match. The other diagonal? No, they don't match. There are 0 lines of symmetry on this thing. So we're going to say, yes, it has 4 sides, but 0 lines of symmetry. Let's look at the rhombus. Is the rhombus the same problem as the parallelogram? Here's a rhombus. Remember, rhombus is like a parallelogram, but all the sides are equal. I can't fold it vertically or horizontally to match, right? Look at that. It doesn't match. The other way is going to do the same thing. Nope, nope, nope. How about diagonally? Let's see. Oh, look at that. So there's one way we can get a line of symmetry, and the other diagonal also gives us a line of symmetry. So it has 2 lines of symmetry, 4 sides, but 2 lines of symmetry. How about the trapezoid? Oopsie, knocking things everywhere. There's our trapezoid. Kind of big. I should have cut it smaller, I guess. It has 1, 2, 3, 4 sides. And what are my lines of symmetry? Well, I could do it this way, and it matches. Can I go this way? No, cannot. And I can't do the diagonals. It looks like it just has that 1 line of symmetry. Finally, let's look at a hexagon. Here's a hexagon, equilateral hexagon. It has all sides are equal. This has 6 sides for the hexagon. Let's look at its lines of symmetry. I can go this way. I can go 2. I can go 3. I can go 4. I can go, that's 1, 2, 3, 4. I can go from edge to edge. There's 5. And I can go from this edge to this edge. And there's 6. So there's 6 lines of symmetry on a hexagon. In a regular polygon, all sides of equal length and all angles are equal. So if we have a regular polygon where all sides are of equal length, like we had this one is a regular polygon, this one was a regular polygon, all sides are equal. Not all sides are equal. This has all sides equal, but let's hold that thought. Not all sides are equal, all sides are equal. And all angles are equal. All angles were equal here, all angles were equal here. They were not equal here, so this is not going to count in our question here. And these had all equal angles. So we're looking specifically at this one, and this one. If all side lengths were equal and all angles are equal, what do we notice about the number of lines in symmetry in the polygons? In this one, we had 3 sides, 3 lines of symmetry. In this one, we had 4 sides and 4 lines of symmetry. And this one, we had 6 sides with 6 lines of symmetry. Yeah, we notice that they're equal, that they have the same lines of symmetry as sides. So if it is a regular polygon with all same side lengths and all angles is the same measure, then you're going to have the same amount of lines of symmetry as you have number of sides. Activity 2 has us making designs that have a certain amount of lines of symmetry. We'll make a design by using more than one pattern block and record our design, draw the lines or lines of symmetry. So we have pattern blocks in the classroom if you want to use those to make shapes, and then you can identify lines of symmetry. They used this trapezoid, this square, and this trapezoid together, made like a candy wrapper sort of looking thing. Line of symmetry this way, if you folded it up, it would match. Line of symmetry this way, if you folded it up, it would match. That's 2 lines of symmetry. What if they want us to make a design with 1 line of symmetry? 1 line of symmetry, okay. I think I would use this configuration of pattern blocks. So I put all these pattern blocks together and I made a fish. And I have 1 line of symmetry here. If I fold this up to over here, I would match. But there's no other way I could fold this so it would match. So there's my example for 1 line of symmetry. Make a design with more than 2 lines of symmetry. Here's my example of 2 lines of symmetry. This line of symmetry here horizontally would give me a fold over that matches, but so would a fold or a line of symmetry here that would also match. So this one has 2 lines of symmetry. Now, how about one with 0 lines of symmetry? There we go. I made a cow or dog or something here that is a shape with these pattern blocks. Any way I fold it, nothing's going to match up. So there I have 0 lines of symmetry. This shape at the right has line symmetry. We're going to draw 2 lines of line symmetry. Okay, well, let's see. How can I fold this so that they match up? I could fold it right down here, fold it right there, and this side would land exactly on that side. Another way I could fold it is maybe right across here. If I folded it there, we'd match. So there are my 2 lines of symmetry for that. And on this part, they just want us to tell whether the shape appears to have 0 lines, 1 line, or more than 1 line of symmetry. We write 0 if it has 0, 1 if it has 1, or more than 1. Well, let's take a look at that first one. What are you thinking? What kind of lines of symmetry? I could fold it here, they'd match. I could also fold it here, they match. So that it falls under the more than 1. More than 1. Let's look at this one over here. What do you think? Yeah, I think you're right. We fold it here, pretend that's a straight fold. We'd get a line, that symmetry, and if we fold it here, we'd get that symmetry too. I don't know if there's any more than that, but there's more than 1, so more than 1. What about some natural things? I see line of symmetry here, for sure. Across here, no, this is a different shape than that. That's not going to match. Across here, no, this would fold over the top of that. I think just 1 line of symmetry on that butterfly. What do you think about this seahorse? I don't think I see lines of symmetry either. Not this way, not horizontal, not vertical, not diagonal. Any way we fold it, we're not going to have any lines of symmetry, so that's 0. And so that's all this lesson is helping us see. How many lines of symmetry do we have? And some practice will make us better. Go ahead and try it on Think Central and see how you do.